Hi, it's Tom. In this series of videos, we're going to go through first a demonstration and then an exercise, hands-on exercise, where we're going to talk about inheritance and interfaces in C#. If you're taking my course, you can actually download this solution, the interfaces and inheritance solution. I'll just give you a quick view of what's inside it and how I ended up creating it. So there's one solution, interfaces and inheritance, with two projects. The first project is a console application, again called interfaces and inheritance. And of course it has the program.cs, where ultimately our console main is. So this is essentially a project that's just going to be testing out some classes that we make. The other project is a class library, and it contains a number of classes that are all related to vehicles. Okay, so if I go into vehicle.cs here, you can see there's a class that represents a vehicle. And then, of course, related to that vehicle class, there's classes called car and truck, and also another class here that might be useful called energy type. So to create this kind of a structure, I just simply went, File, New Project. Actually, I probably created a new solution. The first one I made was the console application, and then I added, said OK, let it do its thing, and then I added the second one, which was the class library. Another thing that I did is in the um, console application project, I needed to make sure I had a reference to the other one. So if I go here to references, I can see that vehicle classes, which is the namespace of, which is the this project here, is in fact being referred to. Right click on it, add a reference. I go to solution projects and I can, just check it off to make sure that um, uh, that I have access to it. Okay, so those were some steps. This is the startup project, that's fine. And basically away we go. Another little thing that I did to keep things organized is in my vehicle classes project is I added a folder. Um, I added a new folder so that I could put my class diagrams. If I only have one at this point, I could put my class diagrams, and it was bothering me that the class diagram is being organized alphabetically. It was mixing it up with the CS files. I just wanted to put it into its own folder. Let's have a quick look at the class diagram right now, so you have a sense of what it is that's being created in this library for you. So as I said before, the main class, or the starting class, is this class called vehicle. Okay, so a vehicle represents, a device used for transportation. I could have went much further into it in terms of defining it, but I've defined it with, it's got a number of fields and a number of properties, a number of methods, mostly related around the whole idea of consuming energy. Okay, so in terms of fields, I have an energy capacity, an energy consumption rate, and an energy remaining. And there's properties that go along with each one of those. So energy capacity, consumption rate, and energy remaining. There's also a few other properties that are not necessarily directly tied to the fields. Well, they're directly tied to the fields, but they're not just simply, returning or setting the actual field. So distance remaining sort of translates the energy remaining into a energy rating and the consumption rate into a distance. Energy is a property. This is actually an automatic property. It's of its own data type, and it represents a type of energy like gasoline or electric. And, you can see here there's an actual class here to represent that. And range, much like distance remaining, range is like the distance that would be remaining if we had a full tank of gas, if you will. So some of the methods, move. So what happens when a vehicle moves from a certain number of kilometers? Recharge and refuel. These actually two methods do exactly the same thing, but it's increasing the energy remaining. There is a ToString method which overrides the base class object's ToString. And then of course there's a constructor. So that's my vehicle class. The energy type class, there's a type which is based on an embedded enumeration, either gasoline, diesel, electricity. That could be expanded obviously quite a bit, but and then also a property called units, which essentially converts this type into either liters or kilowatt hours as it's set up right now. So we'll look at that as well. And then there's a constructor for this class as well. So the energy type class is actually contained inside the vehicle class, okay, in terms of this energy property. Now, related to this vehicle class, you can't actually create any vehicles per se. In order to create a vehicle object, it needs to be more specific, either a car or a truck so far. Okay, so the vehicle class is an abstract class. I create instance class, or classes I can create instances or objects from, two of them, which inherit from vehicles, so a truck and a car. And essentially looking at this, a car is a vehicle that carries passengers, and a truck is a vehicle that carries cargo. So I have fields and properties that correspond to the capacity and the load of either passengers or cargoes, depending on which one I'm talking about. I've overridden the ToString method in the child classes for both cases. I have constructors in both cases. And in terms of the car class, I've also overridden the move method, and we're going to see why. There's a slightly different thing that a car does that I wanted the car to do when it moves that I don't really worry about for trucks or a generic vehicle. So that's the overall picture of where we're going. Well, not necessarily where we're going. This is already coded for you, so it's where we've been, what we're going to look at. Okay, so I'm going to close off the class diagram, and I just want to focus in on the vehicle class to start off with. Okay, so um, there it is. So I have an opening comment at the top. It's focused in on the fact that this is the vehicle.cs file. The purpose of this file is to define the vehicle class. That's me. That's the date that I wrote this. Relatively recent. I'm only using system in this particular file, so I've gotten rid of all the extra using statements that I didn't need. The namespace that I use for all the classes in this library is vehicle classes. And here's where we start the vehicle class definition. So it's a public class. Obviously I want to be able to refer to it outside of this class library. It's kind of the whole point. But it is an abstract class. So abstract means that I can't actually create any vehicle objects directly. Okay, so the entire class can be abstract, and if I have an abstract class, that means I can have abstract members as well. I don't happen to in this case, but I could just simply specify like a pure virtual function in C++. I could designate a method as abstract and only have the implementation in child classes. I digress. So the constructor I've defined down at the bottom simply because I wanted to go through all the different properties and methods and stuff first. But you know, I often will put the constructor up front. So the first property of the vehicle that I want to deal with is what it uses for energy. Okay, so it's a public property. Setting it and getting it, there's no validation or anything along those lines. I've just decided to use an automatic property to represent that. I could have used a public field as well. That would have been just as good. I liked using the automatic property simply because if I need to modify this later on and I do need to add some kind of validation or decide that I want to, I should say, it's easier for me to modify an automatic property and into a regular property than it is to create a whole new property to begin with. Okay, so that's why I've done it that way. But essentially, it's an object of type energy type. So let's take a quick sec at what that is. So this is an object inside of the class. Okay, so it's contained. Here's the definition for it. Oops. Let's make that a little smaller. So again, part of the same namespace. Public, it's not an abstract class. I can actually create objects of this type. It's called energy type. I have a nested definition. In this case, it's a nested enumeration called types. I'd have to be careful with that name if it was not necessarily nested because it's not very descriptive. And I've defined the types. I've only defined 3 for the purposes of this example, but there could be human powered or animal powered or steam powered or whatever, all the various different options. I define the actual enumeration, and then I have in this case, it's a public field called type that actually stores one of those options. Okay, so the object stores one of these, plus I have, it almost is like if I was doing this in C++, I would use a accessor to do the same type of thing. But essentially what I'm doing is I'm using a property that only has a get. It has no set. It's called units, and what it does is it returns either kWh, kilowatt hour, or L for liters, depending on what the type stored is. Now, I've kind of, to do this, a simple if-else statement would have been fine. But I decided to use a switch based on the type that was stored, and I just have one case plus a default. Kind of a waste here, but again, if I were expanding this out to 10 different options and there was more than just 2 different types of units, then this type of structure might have been more useful to me. So I happen to have used a switch in this case. It wasn't necessary. So that's what units does. It looks at the type and tells you whether it's kilowatt hours or liters. And then there's a constructor. So by default, if I don't specify what type of energy it is, the energy type that it'll store will be gasoline. Okay, so that's energy types, which is embedded in the vehicle class. All right. So we have a number of other properties here with underlying fields. My energy capacity is an integer. Okay, it's how much energy can be stored in the vehicle. It has to be positive, so there's a bit of validation for that. The field, the field is protected. Okay, so I can't access it from anywhere, but the property that goes with it is public. So for setting it, I just make sure if the value is either negative or 0. If it has 0 capacity for energy, it's not really a vehicle. I'm throwing, in this case, an argument out of range exception with a fairly detailed description. If no exception was thrown, I'm setting the underlying property to the value. And then, of course, the get, there's really nothing special about that. I'm just returning the value stored in my energy capacity. Energy remaining. Okay, so energy remaining, the underlying property again is protected, much like capacity before it. I actually have it by default initializing to 0. I can either do this in the constructor or I can deal with it here. It's an option that I have in C# or the newest versions of C++. I can do the same kind of thing. But at any rate, the energy remaining property is only kind of like an accessor property. It has a get, but there is no set. So I don't set the energy remaining. I have to refuel or recharge the vehicle in order to get more energy. That was just a design decision that I made. Okay. My energy consumption rate, very similar to my energy capacity. There's an underlying property which is protected. There is a set which is extracting out negative or 0 and throwing an exception if that's the case. Otherwise it sets it and the get returns it. And of course this one's a double instead of an integer. So the energy consumption rate would be, how many liters per kilometer or how many, kilowatt hours per kilometer for the vehicle is consumed. Some other properties, range is a get property as well, so only basically a accessor property. The range basically takes the capacity and divides it by the consumption rate and typecasts it as an integer. The idea is this is how many kilometers you could go on a full tank for this particular vehicle. Distance remaining is almost exactly the same thing, except it's how many kilometers you can go with the vehicle based on how much gas is in the tank or electricity is in the batteries. Here's our methods. Okay, so I have a public method called move, which is a void method. I pass it a distance in kilometers. It figures out if the distance in kilometers is greater than how much I have remaining, that's the property, then it throws an exception with a descriptive message. Okay, notice how I'm using the units. So energy, the energy type. Okay, so gasoline, energy units would be liters. I'm embedding that in the message to make it very easy for me to debug later. Otherwise, I'm returning and then, just the result of this formula, which is the distance in kilometers times the energy consumption rate. I'm rounding that and I'm subtracting it from my energy remaining. Now, this method is a virtual method, meaning that in a base class, and specifically the car class, I may want to override this method to have it do something slightly different. Okay, so I'm using the keyword virtual to allow that to happen. Okay, so the refuel method, okay, it's not virtual, it is what it is. This is basically how I add to the energy remaining. So I have an integer coming in called added fuel, and as long as the whatever energy remaining plus the added fuel is not larger than the energy capacity. If it is larger than the energy capacity, then it throws an exception. Otherwise, it just adds it to the energy remaining. Pretty straightforward. Now, I have the same functionality. I wanted the same functionality but calling it recharge, because refuel just didn't sort of make sense to me in the context of an electric vehicle. So I added an extra function called recharge, and the parameter is called added energy, but internally it just calls the refuel method. So this is just making it a little bit more intuitive for the programmer using a vehicle-based class to, they have options there. And then finally, or not finally, but the next one we're looking at is the ToString method. So this is a public method. I'm overriding the ToString method in the object class. So it's overriding a base class that we don't even necessarily explicitly inherit, but is implicitly inherited. So converting a vehicle into a string, you can go through this in detail if you'd like, but essentially what I wanted to do was I wanted to calculate a couple of things, a couple of percentages, how much energy is left and how much range is left. And then I'm just going through one property at a time, if you will, or one attribute at a time, the energy type and displaying the energy type, gasoline, electric, diesel. This will say something like gasoline consumption per kilometer is, whatever it is. This one would be gasoline capacity or gasoline remaining, maximum range, minimum range, which is the distance remaining, that kind of stuff. I could also add in, and I've commented this out, but I could actually add in what type of vehicle class it is by using this, which is the object that invoked this method, .getType. Recognizing that this is an abstract class, the actual vehicles that we make are going to be something other than vehicle. They're going to be cars or trucks or trains or airplanes. This would actually show that, but we're not quite there yet. We'll leave that the way it is. So finally, the last method is the constructor. Okay, so public vehicle, the constructors, as you know, of course, they don't have a return type. Their name is the same as the class. Okay, so I've decided to make it parameterized. The first parameter is the energy type, which defaults to gasoline. The next one is the energy capacity, which defaults to 50, and the energy consumption, which is the rate, defaults to 0.05. There's some arbitrary values I decided to pick. I want to set the energy property. It's an object, so I'm making it equal to a new energy type object where I pass that type of energy to it. So that sets the energy object that's contained in a vehicle. The capacity equals the capacity, the consumption rate equals the consumption rate, and my energy remaining equals 0. There's no parameter for that. I'm just basically saying, you know, when your new vehicle rolls off the line, it's not going to have any gas in it. So when we create a new vehicle, whatever type it is, it by default won't have any, not by default, it just simply won't have any gas in it until we refuel it. So that's the vehicle class. What we'll do in the next video is we'll look at the two other classes that we derive from vehicle, specifically car and truck.